Dear students, in this video, I am going to show you how to perform the breadth first search on this given graph. Yes, we have a algorithm for this breadth first search. This is algorithm. In the previous video, I have explained this algorithm with an example. But now in this video, I am going to discuss only the example. When you apply this breadth first search on any graph, what you will get is you will get a spanning tree. You will get a spanning tree. Let's see how we can get that spanning tree. Let's start the process. From all these vertices, you have to select any vertex as the starting vertex. So I am going to start from vertex A. And for this process, you have to take a queue. We have to take a queue and whose size is equal to the number of vertices. See here in this graph we have 7 vertices. So your size of the queue also must be 7. And also you need one more array called BFS array. So this is the BFS array which finally contains the BFS order. Now as soon as you select any vertex, you just mark it visited by drawing some cross lines and immediately add that A to the queue. I am adding one more edge here. And now you have to do two steps. First one is exploring. And second one is DQ and add to BFS. So these are the two steps what you have to perform. See the first step, exploring. Exploring means visiting the adjacent vertices which are not visited. Exploring means, see here, visiting adjacent vertices which are not visited. Okay. Now tell me, what are the adjacent vertices of A, B and D? Right? You simply mark B as visited and D as visited. And also you just draw a red line just indicating that you have reached B from A, as well as a red line from A to D to indicate that you have reached D from A, and immediately add these two visited nodes to the queue, right? B and D. That is the first step. The second step is DQ. DQ means, what is the meaning of DQ? Removing a vertex from the front of the queue, right? So at front we have A. So remove this A from the queue and see what we have to do next. Add it to the BFS. So add it to the BFS. Now A is over, right? Now see who is at the front of the queue, that is B. So now let's do the same process for B also, right? Now we are at vertex B. So perform these two steps for B. What is first step? Exploring. What is the meaning of exploring? Visiting adjacent vertices which are not visited, right? Now tell me, what are the adjacent vertices of B? A, but A is already visited. Next one is D. D is also already visited. And see here, C. C is adjacent and unvisited. So we have to take C. And the next one is G is also unvisited and F is also unvisited. So here we have three unvisited adjacent vertices. Now we have to consider them visited like this by drawing a red line, draw a cross line and add it to the queue. Next, draw a red line from B to G, consider it visited, add it to the queue, draw a red line from B to F, okay, consider it visited and add it to the queue. Now first step is completed, that is exploring the B is completed. Second step is DQ. DQ means remove this B from the queue and add it to the BFS. Now do the same process for D also, right? So go to D, explore it. So what are the adjacent vertices? A, which is already visited, and B is another adjacent vertex which is already visited, and C, it is also already visited, but this E is not visited. So you just visit the E from D and draw a red line and also mark it as visited and add it to the queue and add it to the queue. Now exploring of D is also over. The second step is DQ. So remove this D and add it to the BFS and do the same process for C also. So consider C. So for this C, there are no adjacent vertices which are not visited, right? So all the adjacent vertices are already visited. So exploring is already over. Do the second step. Remove the C, add it to the BFS. What is the next vertex? G. So go to G. For G also, exploration is over because all the adjacent vertices are already visited. So remove this G from Q and add it to the BFS. Next one is F. So consider F. So exploration of F is also already over, right? Because there are no adjacent vertices which are not yet visited, right? Next, perform DQ. So remove this F, add it to BFS. What is the next vertex? That is E. Go to E. Similarly, for E also, all the vertices are visited. So exploration is over. Add it to the BFS. Now see here, the queue is empty. When the queue is empty, you have to stop the process. Now, from this graph, okay, from this graph, you have to remove the edges which are not red. See here, this edge is not red, right? It is still blue. That means you have not used this edge. So, since you have not used, you just remove it. Okay, and see this edge also, it is also not used in the process. So, you remove this edge. And also this edge, it is also not used. So, just remove that. And this edge also, and see this edge from between F and C, it is also not used, so remove that. So once you remove all the unused edges, finally whatever the graph you are left with, that is nothing but your spanning tree. It is nothing but the spanning tree. So it is a spanning tree. So spanning tree is nothing but it is a graph with no loops. Okay, so it is having no loops. And also for a spanning tree, if there are n vertices, there will be n minus 1 number of edges. See here, in this we have 7 vertices and there are 6 edges. 1, 2, 3, 4, 5 and 6. There are 6 edges, right? And also see here, this order is nothing but BFS order. BFS order.